This protocol facilitates the construction of excitonic Hamiltonians for the efficient calculation of both optical absorption spectra and the more complex optoelectronic properties of bulk molecular materials.
Our technique breaks down extremely computationally intensive quantum chemical calculations on bulk molecular materials into much more manageable calculations of single molecules that are performed using common quantum chemical software.
Our method can help computationally guide the design of optoelectronic devices using organic materials, such as photovoltaic cells or optical switches for fiber optic communications.
New users should carefully follow the procedure as described, including the suggested file naming convention, and should check that each step has been completed without error before moving on.
For the splitting of a multimolecular system into individual molecules, use the Python 2.7 script getmonomers.py to generate files that contain the Cartesian coordinates for atoms and individual molecules that compose the system. Specify the name of the triposmol2 file that contains the geometry of the system and the number of atoms in each individual molecule that makes up the system, using the command as indicated. To generate ground state point charges for atoms in individual molecules, set up a plain text file called chargeoptions.txt with the options for Gaussian density functional theory calculation of the atomic point charges in the ground state of an electrically neutral molecule. To obtain a reasonably accurate charge distribution for transitions with charge transfer character, use a long-range corrected density functional, a sufficiently large basis set that includes at least depolarization functions on non-hydrogen atoms, a superfine integration grid,